Hi guys, this is Rachel from 3rd CSE, and today I'm going to be explaining my 4th exercise, which is token separation using Lex tools in System Software and Compiler Lab. So here I'm going to perform the same token separation, but only using only as a Lex program. So the Lex tool is something which helps to separate the different strings into different tokens. It will tokenize the given input stream, and the Lex returns the user's expressions and actions. The generated program is named YYLex. The YYLex program will recognize expressions in a stream and perform specified actions for each expression as it is detected. So the general form of a Lex source is going to be, first we're going to have the definition section, and then we're going to have the rule section, and then we would have the user subroutines. So this is how the code is going to look like. Let me just show it to you guys, the code. Okay, this is my code. So as I've explained here, the definition section is going to be first, and this is my definition section, and then it's going to be my rule section, and this is going to be my names user subroutine section. So in the definition section, I'm going to just define whatever like if it's a letter or a delimiter or a digit or an identifier and so on. So this is like the basic thing which is this Lex program will be converted into a C before it is being executed. So this is a basic header file which is in C language. So that's what I've included here, stdio.h, that is standard input output, and int count I have initialized as 0, and these are the definition part where I define the letter, the range like A to Z, small a to Z or capital A to Z, and digits, delimiters and operators and so on. And then here in this part, so the second part is the rules part. So here I'm just going to give the rule, like if it's like either an int or float or double, then it's going to be printed as a keyword and the count will be incremented. And similarly for a letter, as you know, the ID cannot start with a number, it has to start with a letter. So this is the first letter position, and then you might either have a letter or a digit, like as many times as you want, and so the count again will be increased. And then if it is a constant, then you'll have a digit, and then if it is a delimiter and so on, and same goes for operator. And this is the main user subroutine section where you use this YYLex function to call the call what is inside the rules. And then YYWrap is also used to, like if you, this Lex program ends with YYWrap. If you don't, we'll have to end it with YYWrap function call, and then it will return a value 1. So let me show you how this works. So I'm just gonna have to run this code first. This is how I'm gonna execute my program. So I've used Lex exercise4.lex, and then this is for conversion into C. And then when I give ./a.out, it will ask me to enter the expression, and the expression which I have given, as you can see, is int a, b, c is equal to 2, where c is assigned a value 2. So as you can see, the keyword here is recognized as int, and this 1 is the count. So next recognized ID would be A, and as you can see, the 1 has become 2, so the count has been incremented. And then the delimiter I've used is comma, so the count again is incremented to 3. Then a recognized ID B, and the count again is incremented to 4, and the delimiter is 5. I'm sorry, the delimiter is comma, and the count has been incremented to 5. And the recognized ID here is C, and the count has been incremented to 6. And the operator here is equal to, and the count becomes 7. Constant will be 2, and the count becomes 8. So total number of tokens which I have is 8, and these are the different tokens that have been identified. So this is it for my 4th exercise. Thank you for watching.